The timing on this engine has a service procedure that's very specific. The first thing you need to do is to make sure that your idle control is correct. Second thing you need to do is to make sure that your fast idle is set correctly. Third thing is to come here and short 2 wires in here, and that will put the car in check mode. It'll also freeze the ignition timing to, I think, 10 degrees. Then the fourth thing is to loosen the dummy distributor at the back here. Then fifth, put a timing light connected to ignition coil number 1, then point it at the crankshaft. And with your timing light, you should be able to adjust this up until you see 10 degrees before top dead center. We don't have a timing light, we have a scope. Now with a scope, it doesn't matter what we do up here, because all we need to do is to set this relative to the crankshaft, because once we do that, this fixes itself. It doesn't move, and what now moves is the electronic setting of the dummy distributor. Before we do our procedure, we need to make sure that our thermal valve here is set correctly. This guy is completely cold, and our thermal valve is completely retracted. This is a fast idle thermal valve. When hot coolant comes in here, and no, this is not a defect, the factory hose actually is colored white like that. When coolant comes in here, hot coolant, this thermal valve expands and it pushes out. And when it pushes out, it pushes this lever. That lever has a contact on the base, which is connected directly to the throttle. So let me manually move that lever right now when it's cold. You're going to take a screwdriver and I'm going to pry this, and see, the lever will move. And if you watch that leg moves up and down. And if you watch the throttle, it also closes and opens. So right now it's on the cold position, it's partially open. If I pull it like that, it goes to the closed position. Open, closed. And when I say open, I mean partially open. So that's the idea. Now when this thermal valve is completely open, we need to completely clear the throttle body lever. I'm going to focus you there, and I'm going to take my screwdriver again and manually move it. Right now we are at the cold position. When it goes to the hot position, you need to have that clearance gap there. There must be a gap. It should never contact. So that's a first order of business. Let this car completely heat up, and then we are going to see if our thermal valve has clearance. If it doesn't have clearance, we need to give it clearance, and you do that by adjusting this screw here, which in turn will give it more or less gap right here. Let's wait for our temperature to come up, and then we're going to look at that fast idle valve and set it again. We are at operating temperature. Let's go out there and check our thermal valve. That's our fast idle valve, and you can see it's not set correctly. Let me manually move it, and you're going to hear the engine change. Supposed to be up there, and the idle has dropped slightly. So we're going to adjust it until we get that clearance. Okay, the thermal valve is set, and as you can see, we now have clearance completely and the engine is hot. Next, you will need the following things. Number one, you will need an in-cylinder pressure transducer kit. Number 2, you will need your lab scope. Number 3, you will need service information for the Suzuki. And number 4, you will need a donor vehicle. Not any donor vehicle, but a donor vehicle which you can fix ignition timing. This is my work van. It's a Toyota Light Ace. It has a 3S FE engine, and Toyota gives us the ability of fixing the ignition timing at idle. So let me explain why you need a donor vehicle which you can fix ignition timing. If you've ever studied pressure transducers, people like John Thornton, what you will notice is they normally tell you that when your pressure transducer waveform is on the screen captured on your scope, it gives a relatively accurate top dead center, but not exactly top dead center, but as close to top dead center as possible. I've never had anyone explain why that is the case, but after playing around with my transducer, I think I have an answer for that. This is the sensor, but the sensor is connected to a pipe. So this is my pipe. Now if you think about this, your pipe has a column of air in here. If you connect your pressure sensor to the top, it takes some time for the pulse to get here, travel along, and then hit your sensor. And then your sensor will take some time to translate that info into electricity. This will all vary depending on the sensor you have. It's not going to be the same for all. That is why you must use your transducer and get your own information from your transducer. So what we're going to do is to take our transducer, put it on the donor vehicle, disconnect the injector so that we have an accurate pulse, fix our ignition timing on the scan tool as we are taking our capture, and we need to take our capture with the crank sensor and the cam sensor information. When we do that, we need to go into service information for this vehicle and find out exactly where top dead center is on our crankshaft signal. Once we realize where top dead center is on our crankshaft signal, we are going to see the variance at the RPM that we are at. In this case, it's going to be at about 800 RPM. We're going to see the variance from our true top dead center taken from the crankshaft to our pulse top dead center taken from our pressure transducer reading. Once we get that, we'll know the delay. There'll be a delay. We'll know the delay from the time we hit top dead center here to the time we translate it on our pressure transducer. Now with that information, we will go to the Suzuki, hook up the pressure transducer on the Suzuki, and then when we adjust the ignition timing, we are going to offset it with the delay variance that we will have calculated from our donor vehicle. Okay, let's proceed. So we're ready with our captures. Scan tool is ready, scope is ready, and our captures are in cylinder pressure transducer. We're going to take the ignition signal for coil number 1. We're going to disable the number 1 injector. Then we're going to take the cam and crank signal, and my crank signal is down there next to the crankshaft. Then we're going to start the car and take our capture, but we have to fix our ignition timing when the car is running as we are taking our capture. It will only work if you can fix your ignition timing. All right, start the car. We're going to come to our scan tool and we're going to pick our actuation test. And in actuation test, we're going to look for connect TC and E1. The only two data pairs we're going to monitor are the ignition timing and the RPM. So now we're ready, and as you can see, the ignition timing is jumping around. We don't want it to do that. We want to fix it. So we go on, and we quickly stop our scope when it is fixed to 10 degrees. So we jump on, and there it is, and we pause our scope, and that's our capture taken. And just before we go, for those of you who don't believe that a well taken care of car can last a long time, look at this spark plug. That should tell you how clean the burn is inside this engine. And this is a 2000 model. So here's our capture. We're going to use this to calculate the delay of our transducer. Now, from my service information, this is what I have. True TDC is at 0 point crossing of the 11th tooth rising edge, and this is of the crankshaft. So we're going to bring our 0 degree ruler across here, and we're going to put it on true TDC. Let's zoom in here, and we know we are at the 11th tooth rising edge 0 point crossing. So let's count. First, let's bring this down here, and we're going to put it at 0 volts. And let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the 11th tooth. At the 0 point crossing is my true top dead center. So let's zoom in, and we're going to place this exactly there. This one is done. Now let's bring our 360 degree marker, and make sure you change this to 360 degrees. It defaults to 720. We're going to bring this and section off just 1 revolution of the crankshaft. So let's come here. Again, we're going to count our true TDC. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0 point crossing. Put it exactly at the 0 point crossing. And now we have sectioned off true TDC and 1 revolution of the crankshaft. As you can see, our transducer is not at TDC, it is delayed. This is why John Thornton et al. Tell you that this is reasonably close to top dead center, but it's not at top dead center. It is always delayed. So we're going to calculate our delay like this. I'm going to zoom in up here, and we're going to put our ruler right in the middle there. Okay, I'm going to close that, and now this is at TDC. Now to get our delay, bring your second ruler and just put it at 0 degrees, and the delta is 2.08. So we're going to take that information and put it here. We're not done yet. That is just the delay. We need to calculate the RPM of this engine, and that's very easy. We bring this one now, go across, and take it to 360 degrees. Now, which is my ruler here? It's the first one. And our RPM here is 678 RPM. So we are going to say our transducer delay is 2.1 milliseconds at 680 RPM. And this is our transducer delay. We know the delay time and we know the RPM. Now let's go to the Suzuki and we're going to use this information. But before that, we need to get some crucial information from the Suzuki manual itself. Let's do that now. So in the H20A manual, you're going to look for this page. It's a fuel injection control system. And you're looking at the injection timing. It'll give you a chart like this. This is your chart. And there are crucial things here that we're going to use. ECM controls the fuel injection as follows. As soon as the ECM detects 2 pulses of the CMP sensor signal, the ref signal, at the engine start, all injectors inject fuel. Then sequential injection starts and goes on till the engine stops. In sequential injection, injection takes place immediately before the intake valve of each cylinder opens based on the CMP sensor signals, ref signal and pause signal. We're given here the ref and pause signals. We have the ref signals and it starts like this. There's a thick, it goes thinner and thinner and thinner and thinner and thinner. And there's 6 of them, 1, 2, 3, 4, 5, 6. And then it starts again. These are the ref signals to give some information on where to fire the injectors. Now, if you notice here, we are told that this is the ref signal for number 1, number 6, 5, 4, 3, 2. This is the firing order. And then we're told that number 1 is before top dead center, 110 degrees of number 1 piston, and it is the rising edge of this pulse. So from here to top dead center is 110 degrees. Now we know that this is a 6-cylinder engine, so firing sequence between 2 injectors is going to be 120 degrees. So it's just 720 divided by 6. You get 120 degrees. Now with this information, I can now set my ignition timing with my pressure transducer. I will illustrate this on my desk. So I'm going to have a ref signal, which looks like this. And then my transducer is going to give me this here. For now, I'll just call this TDC. Then my ref signal will proceed and I will have another ref signal, which is a bit smaller on this side. This is going to be for cylinder number 1. And from TDC to here is 110 degrees. Now, what I know is this one is going to be the next cylinder over, which is going to be number 6, but it doesn't matter really. What I just know is that on the rising edge of the next one, from here to here, this is 120 degrees. Okay? Now, if from here to here is 110 degrees, and from here to here is 120 degrees, that means from my TDC to here is how many degrees? It is 10 degrees. So what I'll simply do is to put my trigger here, okay, and if I put my trigger here, this will be held on the screen, and all I will do is look for this next ref pulse, and I will section off 2 rulers here and make sure that we are 10 degrees apart over here. And my 2 rulers, to measure that 10 degrees apart, I will first calculate it with these 2 because I know it needs to be 120 degrees. So I'll do some clever manipulation of my rulers there. And when I do this, I will now factor in my delay, and then I'm going to offset this by pushing this one, this side, by 2.1 milliseconds. And while doing this, I have to make sure that I am at or around 680 RPM. This is important because my RPM is the one that I know for sure that my 2.1 millisecond delay is at. If my RPM varies too wildly from here, then my delay is going to be different. And I haven't sampled different RPMs and different delays. It's going to be a bit tricky, but we will manage. In our wiring diagram, we have the crank angle sensor, and the ref and pause are these two here. I don't know which is which. It doesn't matter for me. There are two redundant lines, 53 and 54, and another two redundant lines, 55 and 56. Yellow, green, yellow, and blue. We're going to probe them right at the PCM, and that is 53, 54, 55, and 56. These are our connectors, and we are here. There is our ECU at the driver's footwell, and we are probed. Channel 1 is the pause signal, channel 2 is the ref signal. And out here we have our pressure transducer in cylinder number 1, and it is connected to the green channel. And that's it for now. So there's our capture. We're going to put our trigger on C, and that'll hold it there. I'm going to pause this, and what I want to do is to calculate my RPM right now. So here's what I know. I'm going to bring my degree rulers here. Now I'm going to move away from my misfire section here. We're going to do it here. So we know from here to here is 120 degrees. Put this at 120. Bring this out here. Make sure that I center it properly. And remember, you're referencing the blue channel. Cool. That's 120 degrees. Now we bring our first cursor and we put this at 0. Guys, tell me which other scope can do this. Only the Picoscope. Then we want to see what 360 is. And there it is. So we know that 360 degrees is on the first tooth after this pulse. That's where it is. So from here we count 1, 2, 3. So on the third pulse, that's the thinnest pulse there, and it'll be one tooth. Right now we are at 877.21 RPM. This is much too high for ours. We need to be around 680. That is where our transducer was calibrated from the donor vehicle. But before we go any further, we're at 877. Let's go look at the tach, and I want to see whether our tach is accurate. And guys, look at this. That's our tach. This tach is not accurate. Never use your tach for any diagnosis unless you have physically checked that your tach is accurate. This is an inaccurate tach. We cannot use this tachometer. Alright, so now we're back here and we want to get an RPM of 680. Right now we have an RPM of 877. So we need this to move further out until here. So I'm just reading my RPM as I move out. And there. So this is where we're supposed to be at. And now that I know we're supposed to be here, I'm going to come here and I'm going to lock my time cursor. Not my degree rulers, but my time rulers. Lock it there. That way, if I move this in and out, it's not an issue. Then I'm going to park my degree rulers bring this back here. See, it's locked. Both of them move together. Now what I'm going to do is go to my idle control valve, adjust that screw and drop this RPM until this section here, you remember it was this one, appears on this line. Now it's not just a matter of dropping the RPM. You need to keep checking both of them because when you move this side, it'll also move this side. I'm not going to do it on camera. It's going to take some time. I will just adjust, keep checking, and then turn the camera back on when my target is achieved. Now that we have the correct RPM capture for our transducer calibration, we're going to do some measurements. Let us calculate our engine timing currently. First, I'm going to filter channel C. Then I'm going to come here. We know that from here to here is 120 degrees. So I'm going to center this on that blue channel and call this negative 120 degrees. Only the Pico can do this. And we're going to bring our 0 degree marker and put it on that one. Very good. Now from service information, we know from here to true top dead center is 110 degrees. So what I'll do is to come here, take this out, and put this at negative 10 degrees. That will put our measurement line at true top dead center. Now we know that's true top dead center. Let's blow this up. Let's bring in our degree ruler, line it up there. That is 0. Let's park this, get out of here, and then adjust this to negative 110. Beautiful. Now we are sectioned off true top dead center. And what do you see, guys? See this? Our ignition timing is off. I'll show you that in a minute. So now we are true top dead center here. Remember, we are supposed to have a delay on our transducer of 2.1 milliseconds. So let's take our first measurement here, put it at 0. Then we'll take our second measurement ruler and we are going to delay it by 2.1 milliseconds. So you're going to add 2.1 to 8.86. That is 10.96. 10, not 170. 10.96. Okay, so you can see we have a delta here of 2.1 milliseconds, and that puts us here. Now if I come here and zoom in, I'm supposed to be here, but I'm here. This engine is over advanced, and it's over advanced by 8.8 degrees. Cool. Now we know that we are advanced. What we need to do is to come here and retard our timing. We're going to go to the distributor at the back of the engine, and we are going to adjust it and push this up until it comes to the correct spot. Now, I will not do this on camera. It's going to be a bit difficult fiddling around with my camera while doing this because I'll have to go back and forth on the scope a few times. So let me do it. I will take another capture and then show you that we are at the correct RPM, and I'm going to show you the ignition timing that we will end up with. I've adjusted the ignition timing, and now let's look at our new capture and do some measurements. First, we're going to measure our RPM, make sure that we are within our transducer calibration parameters. Put this at 360. And we'll put 0 here. Let's put them in the right spot. 0 is here. .360 is here. Remember, it was the first pulse. After that, rise. So that's 360 degrees of the crankshaft. And let us now measure our RPM. Activate our two rulers. You put this at 0. You put this at 360. And we are at 683 RPM. And that's within our parameters. Now, let's park these. Let's come here. We know from here to here is 120. Let's put this at negative 120. Center it correctly. Bring this here to the 0 line. And we center it. Good. And let's get our true top dead center. So we just move this ruler here to activate it, and we put it at negative 10 degrees. That is our true top dead center. Looking good on our transducer so far. Now let's put our 0 here and convert this to negative 110. So let's do that quickly. negative 110, and we'll come and put our 0 right on this point here. Excellent. And now let's check where our peak is over there. Remember, our transducer has a delay of 2.1 milliseconds, so it will come after top dead center. Let's activate our 2 rulers, and we'll put the first one at 0 degrees, and that is at 6.282 milliseconds. Then we'll take the second one and put it with a delay of 2.1 milliseconds. So 2.1 plus 6.282 is 8.382 milliseconds. Do that again. 8 point. Oh. My point is acting as a tab. 8.382. So there's our delay of 2.1 milliseconds, and let's zoom in here, and our transducer is exactly where it needs to be. It peaks at a delay of 2.1 milliseconds. Excellent. So this is our proper ignition timing for this engine. Now our cam and crank are timed correctly. The bolts are locked in, and now we're done with the ignition timing. Next, we're going to set the base idle, and then we're going to set the correct idle control position. Now we're going to set the idle. First, we need to make sure that our throttle position sensor is set correctly. Here, it says the TP sensor voltage when throttle is fully closed, 0.5 plus minus 0.15 volts. I set our Picoscope, and it's running, and we are going to get the capture of the throttle position sensor. So let's go to the sensor itself. That is the sensor, and we're going to pin the signal wire. There it is, and that's our voltage. Let's pause and filter it, and we'll measure this. That is 515 millivolts. That's 0.5 of a volt. Our TPS is set correctly. Now let's proceed to set the idle. Next, we will do the idle speed adjust. Now for this, we will need to put the car in check mode. So this is our check connector. We will need to connect a wire here to here. That'll put it in check mode, and your check engine light should flash, and if you have no codes, it should flash a code 12. And then you put a duty meter between here and here. Now I know this happens to be a ground, D, which means F is where our duty is for the idle air control. So we'll just take a channel on our Picoscope, put it in here on channel A, and we'll measure the duty of channel A. And then what we're going to do is take another channel, because we need a tachometer. It says here, warm up the engine using service wire, ground, diagnosis switch terminal in monitor coupler, that is this one, and make sure that the malfunction indicator flashes a code 12. And then stop the engine and connect duty meter between duty output terminal and ground terminal of the coupler. So that is the duty output. Start engine and warm it up completely. Check ASC duty and idle speed. If duty and or idle speed is out of spec, adjust by turning the idle speed adjustment screw. So what we want is the ISC duty to be at 50%, and we want our idle speed to be at 750 plus minus 50 RPM. We have a manual transmission. So now for our tachometer, since we don't have a tach, we are going to take our Picoscope and put a second channel here. So this is the ignition signal for coil number 1. And then we are going to use our rulers and section out our rulers such that the 2 ignition firing sequences equal to 750 to 800 RPM. Let me show you that. So here we are. We've got a wire from ground to this terminal, and that puts the car on check mode, and then you're meant to check whether you have a code 12. There is our dash, and as you can see, we do have a code 12. So that means we have no codes, everything is normal. Then service procedure says we take our duty cycle from here. The next thing is for our tach, we're going to take ignition sync for number 1 from here, and let's go to the scope. So on our scope, I have set my sample rate intentionally low at 20 microseconds because I don't want ignition spikes like this one to come and mess up my trigger. I don't want my ignition coil control to move. Now we're going to measure the duty of this. We come here and we add a measurement, a hole trace, and we want duty cycle. Now notice our duty cycle is 60-70. It's off spec. So what we want is to come to our idle screw, and we are going to unscrew that idle screw until this duty drops to around 1%. So there's our idle screw. I'm going to focus here on that. I'm going to unscrew it while watching the scope until I get 1% duty. So there we go. My duty is around 1-2%. Now I'm going to slowly increase this until I reach 50%. Very slowly. So I've overshot. Let me go back. Okay, now let me come very slowly. So I'm going to leave it there. So now if you notice, I'm around 50%, 48, 50. Look at my average here. My average is around 49.6 and 50%, and that's where I want it. Now I'm going to pause this and we're going to verify our RPM. To verify our RPM, let's bring our degree rulers. Here it's 720. Here is 0. And I'm going to center it correctly. Remember, you are doing it on the firing line, which is when the transistor turns off, not on the turn on. That is here. And we want to measure RPM. Let's activate our measurement rulers. Put the first one at 0. Put the second one at 360. And read our RPM. We are at 749. I'm good with that because we are supposed to be 750 plus minus 50 RPM. And we are at 750. I like that. Now we are going to remove our check connector. Let's come here and remove this from check mode. If you don't do this, if you go and restart the vehicle, it's going to have a problem idling. Then let's go shut off the vehicle and restart it, and we should see a nice ramp up and then slowly come back down, and it should settle down. If we see any hunting on the RPM, then we've done this wrong. We need to repeat. So there is my RPM. Remember, that is lying. It's not accurate. Let's remove the key. You wait a while. Put the key back in. Key on. Make sure you're not in check mode. That check engine light should remain on. And let's start. Watch the tach. Beautiful. That's exactly what you want to see. Now, let me show you what will happen if you leave your car in check mode and start the car. So I've put my connector back in check mode. Let me show you that. Code 21, which means you're normal. Now watch what happens when you start it in check mode. See, it's hunting. Sometimes it even stalls out. So remember, remove the check mode before you start the car again to verify that your RPM comes back down to normal. We are done with the idle speed setting. Okay, next afternoon, now I want to test the fast idle of this car. Let's start it. Has not been started in over 24 hours. Excellent fast idle that it has. No surging, nothing. All right, this is done where the engine is concerned. Now, the radio. The radio circuit is a simple circuit. We've got two powers, one from the 15 amp fuse, and it's on connector G08 pin 10 white, and another one from a 20 amp fuse 17, and that is white on black pin 9, and it passes through the junction connector G12, And then we go to ground and the speakers. So let's pull the radio, pull this connector, and check for powers and grounds. Oh, one more thing. Headlamp relay has an input on pin 8. The reason for this input is to dim the radio display when the headlights are turned on. Alright, here's the radio, and I don't have to do much. Check this out. That is the case for the radio, and we have a bad ground on this radio. Okay, so I have told the owner about this because we need to rip apart the dash in order to get to that ground. It's under the dash. The owner has told me that he's selling this car and he doesn't want the radio repaired, and that'll be the next person's issue. All I'll do is to tell him that before even they do anything, they need to repair the ground for this radio. Alright, that's it. We are done with this Suzuki. Another one for the books. See you next time.